Hey, it's Glines from the Automator, and this video is just a little extract from one of our hero calls where Dale had asked about how to check for where your code's running slow and how to well, not how to optimize, but how to actually figure out which parts of your code are not performing optimally. And so Isaias just walked through. We did some talking about different ways you can check, things you can do. Also, just remember, first thing you want to do is do pseudocode, right? Don't be optimizing your code. Write your outline of your code, get that structured, write your code, and then go back and now start optimizing things. Anyway, check out this video, like it if you enjoy it, really helps us out. Also, if you're interested, consider this hero group. It's just another question someone asked randomly, and it's just great. You can get this kind of input and bounce ideas off of us because Isaias is really good at what he does, and we have lots of ideas. Have a good day. Cheers.
I have a general question. Is there a way to someone says, "Oh, my script is running slow," but like to profile the code and says, "Well, it's spending a lot of time in this function or this class or something." I don't know if VS Code does something like that.
Not exactly, but you can do something to check the performance of your code or even part of your code. What we did and what I have is that I added it to prompt assistant. You can have a hot string if you want for this. Let me show you what I mean. So let me share my screen real quick here. With this because last time I tried very hard. Okay, to do this the right way, but it was not working. So that was okay, cool. So I even have it in prompt assistant now. And actually I have it in one of my sub menus. So if I want it, I can just press this hotkey here and I will just bring this up. And the one that I'm looking for is the one that says performance. And this is a piece of code that you can find on the help file, all right? And from the help file, I copied it, I put it in prompt assistant so that I can have access to it whenever I want. And what it does is this. The first part is that it starts a frequency variable with a value. It tells this script what is the frequency of your CPU, how many cycles it does. Then we start a counter where we start a timer first, then a timer after. And then what we do once we finish up with what we want, so whatever code you want has to be here in the middle. The code that you want to measure should be here in the middle. So this is when we started counting. This is when we finished the actions. And then you're going to do that. You're going to subtract the after from the before divided by the frequency of the CPU. And that's going to tell you how many seconds it took to work. But what we do is that we multiply it by 1,000 to know the milliseconds. If you don't want the milliseconds, if you want to see the seconds, you can remove this part, right? Now, this is a very big roundabout way of doing it. There are other ways that you can do the same thing a little bit simpler. Like, for example, you can have a variable called start, and you can say a tick counter, a tick count, sorry. You can capture the count at this point, have your code, and then your end would be a tick count here. And then your time, your end time would be end minus start. That's it. And this is also in milliseconds already. Now, why would I do one over the other? Why would I use this instead of this? It has to do with the precision. So if you want to see just milliseconds, this is good enough. You can just do this real quick. And it doesn't take too long. And we're going to test it in a second so you can see the difference. But if you need fractions of milliseconds, like if it is something so fast that you need to see the fraction of a millisecond, then you will need this guy. So my default is to use this one because the the resolution of it is so tiny that I can really tell if it is a problem or not. But mainly, if you want something quick, just realize that you just start counting at one point, end your counting after the code, and then just subtract the two and you will get your answer. So let's do that. Let's have a loop here. And the loop is just going to tooltip a index, right? And then let's comment all of this out. And I will take a look at how much time the computer takes in milliseconds to do 50 loops, 50 rounds of just this. And when I do that, it tells me it took 62 milliseconds. That's the difference, all right? Now, if I add a sleep in here, you will see that now it took almost a second. Does that make sense? Because this just tells me the difference between when you started and when you ended. All right? Now, at this point, if you have a piece of code that you want to know, like a function, then you have a function call. You put your ticker at the beginning of the function call, and you put the ticker at the end of the function call, and then you realize how long it takes. And this is the way how I tell whether a piece of code is bad or not, right? So there are some things that you look at it and you say, if you have a loop, that inside a loop, it has another loop, and inside that loop, it has another loop, you will see that that is going to take a long time to do something small. So that's how I find out, okay, you know what? That function is the one that is making everything slow. I just move this piece of code around and I put in between the two parts what I'm looking for. Let's do the same thing with the other one. So this is the same thing. I'm gonna do the loop. Loop 50, a tooltip, index here, right? And now, let me make this a message box. But this one, you will see that it will not say 64. It will say 68.8622. So that's 68 milliseconds and a fraction of a millisecond. Does that make sense?
Not really.
So this
mind-blowing.
Right, it is mind-boggling of how fast it really is. I don't think you need this most of the times.
No.
Right? But there are some situations in which this makes sense. And again, as I mentioned, it's because I'm multiplying it by 1,000. If I do this, it should give me the seconds, actually. And what it's going to do is 0.05 seconds. You know, it's not even 1 second. All right. It's just 0.05 seconds is what it took. All right. This is the interesting thing. 100,000 of those. How long do you think it's going to take? And that's the weird thing about computers. If we look at it, 100,000 things, it's like a lot of things, but in the end, it's going to take like a few seconds. That's at most. Let's make it 10,000 so that it is not, we don't wait that long. But when you think about it, just imagine, can you do 10,000 actions? I don't think so. And this thing in 10 seconds did 10,000 of those, right? So
well, hold on a second. Remove that tooltip and just do an index counter. I'm just saying, because you had a graphic there, right? If you didn't have a graphic there, the time would be insane. And how
look
fast?
at that.
Yeah. See,
it did 10,000 of nothing. Not even
which
1 second.
It's a really important lesson as well. GUIs, even a tooltip, really slow down your script, right? Like it's crazy as a ratio. Like, wow, man.
At this point, you see how fast that is. I'm doing 100,000 of those, right? At this point, seconds are not a good measurement of time. That's the reason why we go ahead and measure in thousandths of a second. And basically, at this point, we know that it took 3.97 milliseconds to do 100,000 counters. And actually, in the end, I can message box the counter and I will get
right
thing, right? So it will take no time whatsoever, but still it did do the action of adding this number 100,000 times.
Now, Isaias, sorry, go back to the adding the tooltip in, just like it was initially where it was slower. But let's use the tooltip, do it on the do the tooltip on a mod of every like 100th time. This is where the loops still happen. We're not negating that the loops happen all the time. It's how often we're going to update the tooltip, right?
Okay.
So
Let me see.
this is
Okay,
where you realize if you do want to
I have
have
to say, if mod, then tooltip A. This is what I want to do.
Yeah.
All right, cool. There it goes. So if I don't have this condition here, well, I cannot do 100,000 of those. It takes too long. Yeah. So let's do this. So this is what it looks like when I don't have the condition, right? And it took 10 seconds more or less, right? A little bit more. Okay, 10 seconds, right? But if I just, the only thing I do is that I just display the GUI every 100 times, which is what that means. I will explain a little bit more on that in a second. So you will see that now it takes 126 milliseconds. It's so fast, just because you do it every 100. Let's make it every 10 times. Okay, so still less than a second, just because you, by a factor of, 10, a factor of 10, if you just go ahead and added this thing, you just wow, that's crazy. Now the thing is, and this is what you have to understand, how mind-boggling fast computers are right now. This is crazy numbers.
Well, and keep in mind, AutoHotkey is quote unquote slow, right? Because
AutoHotkey is an interpreted language, which means every line of code, every line of your code must be read and then converted to something else before the action happens, which means compared to something like C++, C#, Java, and any other language that could be compiled, like Go or Rust, any other language that could be compiled into binary. I think even Python, I don't know if Python is compiled into binary. I think Python is also interpreted, by the way.
yeah.
So interpreted languages are what we call slow. Look at how slow that is.
Yeah.
That's not slow.
Dale, what I used to, when I was used to actually really develop, my own stuff, what I would do is I wouldn't have like in a loop there with the tool, but it was always helpful to at least at the difference, like, was it David mentioned the mark, like the bookmarks and knowing, jumping. My point is, everywhere you have a significant step of your process, just notifying you of, oh, I hit this one, now I hit this one. That can often help you understand what parts are taking it without doing all the counting stuff that Isaias is doing, right? Because often you think something somewhere is taking the time and it's not. It's actually somewhere else entirely. So just pinpointing first, where is all the time being taken? Like that you can do with the tooltip, just, and watching it and going, oh, I'm somewhere in between here and here, right? Like without even debugging or anything. That's just really easy.
Right, exactly. And that's a part of how I usually do this, by the way. Some people, as soon as they start coding, they want to make it performance ready. And that's not how you do it. You write the code to make it work first. Once it is working, then you figure out, oh, look, whenever I click in here, it gets really slow. So let's look at that. And then you go place those two, the AT count at the beginning, at the end, and see the time. But you do it for the whole function first, until you find the function that actually is the one causing the problem. Once you find the function, then you go part by part, moving those around to see what is the part that takes the most time. And then you will pinpoint what you're really looking for. And then you make changes to that part of the code. Don't rewrite the whole function just because it's slow. You see what I mean? Some people do that.